Exponential functions are often discrete, meaning not continuous. For example, interest is often paid only once a time period, whether it's once a month, once a quarter, once a year. It's only paid then. So if you have a certain amount on your account and you don't put anything else in there, your graph isn't going to increase cent by cent by cent. It'll increase by blocks every time they put interest in your account. Okay, that's discrete, meaning we can't connect those dots because it's not always ever going to be that point in the middle. It'll always go from what you have at the end of the month to what you have at the end of the next time they put interest in. The graph of an account's balance would consist of individual points corresponding to each time interest is paid. To model a discrete situation using an exponential function of the form y equals a times b to the x power, we first have to find the growth or decay factor. If we know the y values for two consecutive x values, we can find the rate of change, r, and then find b using r equals our second y value minus our first y value, all divided by our first y value. And we can use the fact that b equals 1 plus r. Guys, r here is going to be a percentage. So it's just like when we found percent change. We subtract where we ended minus where we started and divide by our original amount. So if we look on page 438, it shows the world population of the Iberian lynx in 2003 and 2004. If this trend were to continue and the population is decreasing exponentially, how many of these lynx would there be in 2014? And then I'll have you guys try in 2020. So if we look there, we have a couple ordered pairs. We have 2003 and 150. And then we have 2004 and 120. So these are consecutive, which means they go from 2003 up one more to 2004. Consecutive means next to each other. So I'm going to define my variables here. I'm going to have x be the years since 2003. Since that's where I'm starting at, I'm just going to go right there. Rather than have huge numbers and have to deal with 2003, I'm just going to have it be years from there. Okay, and my y is going to be the number of Iberian lynx. So we're going to start off with our base equation. Our base equation here is y equals a times b to the x power. We know what b is though. Y equals a, b is 1 plus our rate. So in order to find that r value, we're going to have to subtract our y's, y2 minus y1, and divide by our original. Our second y value is 120 minus our first y value of 150. And again, we always divide by our original. This here is going to give me negative 30 divided by 150, which gives me a rate of negative 0.2 or negative 20%. Okay, now that we know what r is, we can figure out our b. We can take it and plug it in. Get y equals our initial amount we know. Okay, we know our initial amount is 150. 1 plus negative 0.2 to the x power. Just going to simplify that to 0.8 to the x power. Okay, now we want to know here how many there's going to be in 2014. So we have to figure out how many years it's been since then. So 2014, subtract 2003, that's where we started, and we're going to get 11. We plug that 11 in. And we are going to get approximately 13 when we type that in our calculators, which means if the trend continues, there's going to be approximately 13 Iberian lynx in the wild in 2014. Okay, recap here is repeated multiplication can be represented with a function in the form of y equals a times b to the x power. B is a positive number other than 1. An exponential function is a function where the general form y equals a times b to the x power, as long as a is not 0 and b is greater than 0, and b can't be 1. In an exponential function, the base b is a constant. The exponent x is the independent variable with domain the set of real numbers.